Swift at Apple migrating the password monitoring service from Java. Swift is heavily used in production for building cloud services at Apple with incredible results. Last year, the password monitoring service was rewritten in Swift, handling multiple billions of requests per day from devices all over the world. In comparison with the previous Java services, the updated backend delivers a 40% increase in performance along with improved scalability, security, and availability. The password apps introduced in the fall of 2024 helps users manage their password, passkeys, and verification codes. It allows them to store, autofill, and generate strong passwords that can be shared across all their devices, as well as share passwords with trusted contacts. One security feature included in the app is password monitoring, which warns users if one of their saved passwords shows up in a data leak. This feature has a server component running on Linux-based infrastructure that is maintained by Apple. On a regular interval, password monitoring checks a user's password against a continuously updated and curated list of passwords that are known to have exposed in a leak. Importantly, this task is handled in a thoughtful, privacy-preserving way that never reveals users' password to Apple. A detailed discussion of how this is done using cryptographic private set intersection protocol is in the password monitoring section of the Apple Platform Security Guide. The migration from Java to Swift was motivated by a need to scale the password monitoring service in a performant way. The layered encryption module used by the password monitoring requires a significant amount of computation for each request, yet the overall service needs to respond quickly even when under high load. Choosing Swift for increased performance. For years, our team relied on Java to power large-scale mission-critical services because of its proven stability and performance. However, Java's memory management approach no longer aligns with our growing demands and efficiency goals. Instead of simplifying expanding hardware resources, we were seeking a more efficient language to support our growth while reducing server overhead. Prior to seeking a replacement language, we sought ways of tuning the JVM to achieve the performance required. Java's G1 garbage collector mitigated some limitation of earlier collectors by introducing features like predictable pause times, region-based collection, and concurrent processing. However, even with these advancements, managing garbage collection at scale remains a challenge due to issues like prolonged GC pauses under high loads, increased performance overhead, and the complexity of fine-tuning for diverse workloads. One of the challenges faced by our Java service was its inability to quickly provision and decommission instances due to the overhead of the JVM. The password monitoring service runs globally, so service load can greatly fluctuate throughout the day, even with client-side techniques to smooth over the distribution of traffic. The peak and trough of a day differs by approximately 50% regionally. To efficiently manage this, we aim to scale down when demand is low and scale up as demand peaks in different regions. A faster bootstrap time is a crucial requirement to support this dynamic scaling strategy. Given the scale of our application and the volume of traffic we manage, the decision to transition from Java to another language was not made lightly. We evaluated our options and found only a few languages that could help us achieve our goals. While you might expect that Apple would automatically choose Swift, we were pleasantly surprised by how well it fit the unique needs of a cloud-based service like ours. Swift has expressive syntax that was easy to learn and could deliver the performance improvement necessary to meet the demands of our compute workloads. We decided to take a significant leap and started a rewrite of the password monitoring backend using Swift. Our experience developing with Swift, we began rewriting our service using Vapor, a Swift web framework that provides a routing, controller, and content modules that we were able to build upon. Our service has additional requirements that led us to create a few custom packages with essential functionality, elliptic curve operations that are crucial for implementing password monitoring, auditing, configuration, error handling, and custom middleware. One of the most significant aspects of Swift that impressed us was its emphasis on protocols. In Java, we relied heavily on inheritance, which can lead to complex class hierarchies and tight coupling. Swift's approach of protocol and generics promotes modularity and reusability by allowing classes, structs, and enums to share common protocols, enabling a more flexible and scalable code base. This shift in mindset encouraged us to think in terms of behaviors rather than concrete classes, resulting in cleaner and more maintainable code. Safety is another area where Swift takes a distinctive approach compared to Java. For example, Swift's optional type and safe unwrapping mechanism eliminate the need for null checks everywhere, reducing the risk of null pointer exception and enhancing code readability. This safety first approach ingrained throughout Swift language design, whether it is deterministic deallocation, copy on write, or value types, makes it inherently less prone to runtime errors. Swift's async awaits award is a nice addition, streamlining how we handle async tasks. Previously, managing async operation often involved complex callback patterns or external libraries. Swift's async await syntax simplifies this process, making it more intuitive and less error prone. We can now write async code that reads like sync code, leading to more readable, testable, and maintainable concurrency handling, especially critically in high load multi-threaded environments. Overall, our experience with Swift has been overwhelmingly positive, and we were able to finish the rewrite much faster than initially estimated. Swift allowed us to write smaller, less verbose, and more expressive code bases, close to 85% reduction in lines of code that are highly readable while prioritizing safety and efficiency. Our services benefited from a diverse ecosystem of Swift packages, including logging frameworks, a Cassandra client, and crypto libraries that were readily available. In addition to excellent support system and tooling, Swift's inherent emphasis on modularity and extensibility helped future-proof and simplify the integration and customization needed for our service-specific function. Takeaways for future Swift on server development: we benchmarked performance throughout the process of development and deployment, allowing us to discover the trait of the Swift programming language that delighted us the most: its efficiency. Swift deterministic memory management led to much lower memory threshold for our service. Not only were our initial results hardening, but after a few iterations of performance improvements, we had close to 40% throughput gain with latencies under 1 millisecond for 99.9% of requests on our current production hardware. Additionally, the new service had much smaller memory footprint per instance, in the hundreds of megabytes, an order of magnitude smaller compared to the tens of gigabytes our Java implementation needed under peak load to sustain the same throughput and latency. The service runs on Kubernetes, and the migrations efficiency improvements allowed us to release about 50% of its capacity for other workloads. Our Swift implementation has run smoothly and efficiently in production, making it worth the effort we put into this migration. In addition to outperforming our previous Java-based applications, Swift delivered better performance, consistency, and enhanced safety features and robust reliability, all while requiring fewer resources by utilizing memory and CPU efficiently. With fewer lines of boilerplate code and more flexible design patterns that we used, we look forward to simplified maintenance of our application. Swift was a powerful choice for building fast, resilient, and maintainable application in our high demand environment. Yeah, that's it. Thank you for watching. Bye.